So this is the WA2 Online Revision event. Maybe I'll just do a quick introduction to myself first. So I'm Ashley. So I've been teaching chemistry at the secondary school level for 12 years. I was previously working as a textbook editor lah. Okay. So the OVERMUGGED brand. So currently we have 8 branches across Singapore. Later, if you're interested, I'll show you the class schedule. Then if you're interested to sign up, you can always just scan the QR code and look at the website. Okay, so at the end, so if you are one of our regular students, the chances are you will definitely get about 70, you'll definitely get a distinction at your national exams. Then these are some of the resources we offer. So the curated notes, the weighted assessment revision like today. I think in June or in September, they're probably going to do a mock exam. And then as well as after June, there should be some practical stuff that's going to go on. So yeah, these are the resources we offer. So I think all of you here today are primarily more interested in the revision itself. So today's agenda is actually to go through electrochemistry. So I'll do a content summary first, and then after that, we will look at some more commonly tested exam questions. Then after that, I'll do a debrief whereby if you have any questions you want to ask, please do feel free. I know that there are 2 groups of students here today. So there are those who do O levels and those that are doing IP. So in the content summary itself, I will clearly state which part, what kind of equations is expected of O-level students and what type of equations are expected for IP students. So yeah, please do take note. Okay, yeah, that's that. And then yeah, so if you have not received the materials, please do feel free to scan this QR code. I will put the Google Drive link just in case anyone is late and wants to come in and can't find anything. Okay, just give me a minute. Sorry, just give me a minute. I'm trying to pull something up. Yeah. Okay. So I'm gonna put the Google Drive link in the group chat now. Just give me a minute. Okay. Okay, so without further ado, I'm gonna start on this lesson on electrolysis. Okay. Yep. Okay. Now, all of you should be able to see this summary notes that I've created for you. This is like the secret manual you will need to conquer electrochemistry. So this should be found inside the Google Drive link that I have provided everyone, or the QR code. When you scan, there should be 2 documents, one on the notes and then one on this summary. So the notes itself, basically what happened is you should be able to receive the OVERMUGGED curated notes, but I think technically this is the common problem that I think all schools face, is that most of your teachers in school teach you through examples and not really a set of skills or set of thinking framework. So what I'm going to introduce to you today is to kind of compartmentalize your thoughts. Okay, so basically what happened is when you're dealing with an electrolytic cell, what are you dealing with? So electrolytic cell, basically the idea is that you are trying to use electrical energy, or you are trying to use electricity to generate or to initiate chemical reactions. So technically, the chemical reactions that you're going to be dealing with is all written up here. There are the three primary types, which is electrolysis, electroplating, and electrolytic purification. So what happened is, when you are trying to solve electrolytic cell questions. So what is an electrolytic cell? Basically, the setup consists of the battery. So what happened is, in the process of doing the question, what you need to do is you need to apply two steps, or rather two things. First thing is you need to dissect the diagram itself. So you will be given a diagram, you need to know how to dissect this diagram. So based on the diagram itself, you need to be able to work out your anode and your cathode and everything. Understand? So that is the first thing. Then what happened after that is, then after that, what you do is you use the framework to try to work out what are the chemical products that you're going to get, what are the chemical reactions. Now, what I want you to think of in all times is that when it comes to electrolysis question or electrochemistry question, it's not that difficult. Primarily, what they are asking you to look at is, number one, the chemical reactions that happen at the cathode and the anode. So you must be able to come up with the chemical reactions and tell them what are the products formed at the cathode and the anode. Number two, what are the observations you see in regards to your cathode, your anode, and your electrolyte. So what you want to achieve is these two things when you're doing electrochemistry. Okay, so what we're dealing with right now is the electrolytic cell. So like what I say, electrolytic cell is to use electricity to initiate chemical reactions. The chemical reactions is primarily electrolysis, electroplating, and electrolytic purification. Okay, in an electrolytic setup, electrolytic cell setup, you will have a battery attached to your electrodes and is deep inside an electrolyte. So like what I was saying just now, step one, or the first thing you should do is to dissect the diagram. So I'm going to first start you off with dissecting the diagram. Now, how do you dissect the diagram? So what you need to do is you look at the battery. The battery got a long side and a short side. So the long side is positively charged and the short side is negatively charged. Okay, that is the first thing you need to do. Okay, so you need to know that your long side is positively charged and your short side is negatively charged. Okay, wait, something is wrong. Wait, give me a minute, sorry. Okay, sorry. So like what I was saying, right? The first thing you do is you look at the diagram you have, you dissect the diagram. So the long side of the battery is positive, the short side of the battery is negative. The electrode that is attached to the long side of the battery is also positively charged. And the electrode that is attached to the short side of the battery is negatively charged. Next. So let's take a look at this positive electrode. So this positive electrode, if you think about it, is positively charged. So what it will attract is, it will attract anions. Okay, why attract anions? Because anions are negative ions. So a positive electrode will attract a negative ion. Now, if you think about it today, if you open up a shop and then primarily your shop is to attract anions which are negatively charged. So what happens is when the anions see your shop, they must be immediately be able to identify your shop. So you think about it, if it's anions, then what likely you're going to call that shop is anode. So once the anion see anode, that means I'm supposed to go there. So the logic thinking is this: positive terminal, positive electrode, attract anions. So we call that the anode. Next, On the other side, if you use the same logic, then negative terminal, negative electrode, it will attract your cations, which are positively charged. So what we should call it is the cathode. Now, in chemistry, there is this undying rule, which is called the N-ox-Red-Cat rule. So what is the N-ox-Red-Cat rule? N-ox means anode undergo oxidation. So at the anode side, what you're going to see is a oxidation reaction. Cathode reduction. So what you're going to see is a reduction reaction at the cathode. So step one, dissect your diagram, figure out where the anode and the cathode is, and then figure out what type of reaction you're going to get. Now, if you recall, this is linked to redox. So in redox, what you learn is oxidation will lose electrons, meaning that your reactant loses electrons. So the electron will be produced, it will come from the anode side. So that's why you see electrons are coming out from the anode. Next, cathode will gain electron. So if you think about it, your reactant need to consume the electron, need to gain the electron. So the electron must go to the cathode. So second thing that they like to ask you is, draw me the arrow to show where the electron flow. Okay, so first question type, where is the cathode, where is the anode? Second question type, where is the electron flow? Give me a minute. Okay, that's it. So sorry, let me repeat myself. First exam question type is to identify where the cathode and the anode is and what kind of reaction happened at the cathode and the anode. Second question type is where the electron will flow. Now, once you finish the diagram, then it's time for you to predict the products that will happen at the cathode and the anode. And this is where you will use the framework here. Now, the framework consists of three very important questions. So the first question you ask yourself is, with regards to the electrodes. So you look at the electrodes. Are the electrodes inert or reactive? Now, what is the idea of inert? Inert means it does not participate in the reaction, or they do not participate in the reaction. So that means they are not going to react, okay? Whereas reactive electrodes means that they will participate in the reaction, which means that they will do chemical reactions. So your first question is, you ask yourself, okay, I look at the electrodes, are they inert, are they reactive? Okay, so what happened is, I have two choices here. We follow the inert trend first. So we follow the flow chart for inert. So let's look at, if I choose inert, then what I need to do is to then ask myself the second question. So the second question I'm going to do is, I'm going to look at the electrolyte. Is the electrolyte molten or aqueous? So molten basically means that there is no water. Aqueous means that there is water. Okay, so what we're going to do is we're going to look at the molten state. So in the molten state, that is where you get your first scenario or the first possible question type that your exam can come out, which is inert electrodes, molten electrolyte. So in inert electrodes, molten electrolyte, what you need to do is you look at the electrolyte, dissect the salt. So the salt has Na plus, Cl minus. Then you send them to their respective electrode. So the cation, which is Na plus, will go to the cathode. The Cl minus, which is your anion, will go to the anode. Then basically what you need to remember is, do you really need to hard memorize the equation? The answer is no. Because if you realize that most of the situation is, if you get a metal ion, what you're going to end up with is a metal. So meaning like sodium ion will give you sodium metal. If you get an N ion, or rather if you get a non-metal, so if you get a non-metal ion, most of the situation is you will end up with a non-metal. But what you need to take note of is the non-metal doesn't become an atom because we know that chlorine atom cannot exist. So chlorine will exist as a chlorine gas. So if you can see here, non-metal ion give you non-metal. So what you need to then remember is where to put your electrons. So if it's positively charged cation, you put it together with it. If it's negatively charged N ion, put it in the opposite side. So that clears your first possible scenario that you're going to get, molten electrolyte. Okay? Anyone have any questions here? No, I think we will deal with the harder ones, which is aqueous. So from question number 2, if your electrolyte is an aqueous electrolyte, then what you need to do is you need to ask yourself the third question. Is the aqueous electrolyte dilute or concentrated? Now, this is where O-level and IP syllabus will start to differ a little bit. So please pay attention. If you're from O-level or if you're from IP, no matter what, yeah, please do pay attention. But I have kind of tagged it quite well. So if you are O-level student, you will follow this. If it's an IP student, you'll follow this. Okay. So let's first deal with a dilute electrolyte. So for example, I have a dilute aqueous electrolyte like dilute NaCl. So after you dissect the diagram and you ask yourself these 3 questions, then you arrive at here. What you need to do is look at your salt and then dissect your salt out. So the salt will split up to give you Na plus and Cl minus. Then because there's water, so what you need is H plus and OH minus. Now take note, this is for O-level. So for O-level students, you need to split the water up into H plus and OH minus. Okay. For those IP students like Hwa Chong as well as River Valley as well as Nanyang Girls, what happened is you don't split up your water. So you just put water on the Na plus side as well as water on the Cl minus side. Then what you need to do next is to send them to their respective electrodes. So for example, Na plus, H plus, or water for the IP students, you send them to the cathode. So now, unlike the molten electrolyte, in dilute aqueous electrolyte, there are a few cations there. So what you need to do is you need to select one of the cation to discharge. So how do you choose? Your choice is based on reactivity series. So if you recall in metals, we learned about reactivity series, potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, okay? Then lead, sorry, not lead first, iron first. TIT, tin, lead, hydrogen, copper, silver, gold. So for the O-level students, basically what you need to do is you just need to see where is the ion. The lower the ion, the more likely it will get discharged. So between Na plus and H plus, if you can see, H plus is here, Na plus is higher up, so you will choose H plus. So the H plus will get discharged. This is for the O-level students. Next, for the IP students, unfortunately, you need to insert this. So besides H plus, which is hydrogen, you need to insert water in this position here. So your water will be found between zinc and iron. Okay, so this will complete your reactivity series. Now, based on what I remember, Nanyang Girls, they say that the table will be given for you during your exam, so you don't have to memorize. Whereas I think for Hwa Chong students, you will need to memorize this. So just remember to put water between zinc and iron. Then once again, it's based on position, the lower the better. So for example, if it was sodium versus water, then you will choose water. But if it was sodium versus acidic water, then you will choose H plus. So for the IP students, basically what happened is that if your electrolyte is an acidic electrolyte, you will have to choose H plus. If your electrolyte is a neutral or basic electrolyte, you choose water. So that is basically how you deal with the cation or the cathode. Next, we have our Cl minus and OH minus, as well as water for the IP students. So we'll send this set of ion to the anode side. So for the anode side, there's Cl minus and there's OH minus. But if you are from IP, you will use water. Once again, this will be based on the electrochemical series. So if you recall, the electrochemical series is SO2, SO4 2 minus, NO3 minus, Cl, wait, let me think about this. Sorry, I don't memorize this series. I'll tell you why I don't memorize, okay? So it's SO4 2 minus, NO3 minus, Cl minus, Br minus, I minus, and then OH minus. Okay? So basically what happened is, same thing, if you see, you're going to choose OH minus because it's the lowest in the series. Now, basically I explained to everyone why I didn't bother memorizing this electrochemical series. Because if you look at past year TYS question, every year will be water. There's never a situation whereby the solvent is not water. It's always an aqueous solvent. So for those of you who are doing O-levels, you think about it, if you're going to ever get aqueous solvent, it means that there will be water. And if there's water, there's going to be OH, which means that you will always have to choose OH minus. So rather than try to remember this series, what you should do is you just need to remember, you always just need to choose OH minus because OH minus is the lowest in the series itself, correct? So rather than to waste your memory space on trying to remember the electrochemical series, what you should remember is the equation in which OH minus get discharged. So I justify my rationale again. Number one, why I say you shouldn't memorize this electrochemical series for N ions is because number one, if you look at past year TYS question, there was never a situation whereby they give you a different solvent. The solvent that you always will get is an aqueous solvent. So you are always going to get aqueous electrolyte. Almost like I can be confirmed 99.9%. I'll just give myself a 1% error. But 99.9% is always going to be aqueous solvent. If you have aqueous solvent, you have water. And for you, when you are doing O-levels electrochemistry, water, you will need to split it up into H plus and OH minus. So as a result, your N ion or your anode will always have OH minus. So which is why you always choose OH minus. So rather than to remember this and then derive out that, oh, OH is at the bottom, just remember, always choose OH and then just remember this equation. So this equation you should memorize because it's not a very easy equation to derive. Next, for the IP students, unfortunately, is there is a differentiation because your school wants you to remember water. So if you have water, then where is the position of water? Water is found here. So water is found between chlorine and bromine. Okay, so what happened is water is found here. So what you need to do is you just need to remember. So for those IP students, then I would recommend you to remember this. But I think same thing. Nanyang, the series is given to you. Hwa Chong, you will need to memorize. Same goes for RGS, I guess. So what happened is you insert the water between the Cl and the Br. So in that situation, then what happened is you will choose water. So if you think about it, in a basic medium, you have OH minus, you choose OH minus because it's lower in the series. But for water, it's higher up in this. If you have a neutral or acidic medium, you only have water. So you choose water to get discharged. Okay? So take note, for IP students, you need to remember the series and you need to remember where to insert water. For the O-level students, you only need to remember reactivity series. And then for your anode anions, just always choose OH minus. So all in all, what you need to do is based on the series itself, just choose the one that is always lowest in position. Okay, then next thing to take note of is, which I didn't write it here, is what are the observations you're going to get. So at the cathode side, you will get H2 gas. So you must also remember how to test for the H2 gas. So not just observation, but the chemical test. And then same thing for your anode side. Your anode side will always produce O2 gas. So you must remember the observation plus the chemical test. Okay, so that concludes the second scenario. I hope I'm clear. So remember, cathode, send all your cation ions there. Choose it based on reactivity series. The lower, the better. For O-level students, just need to choose H+. So you just need to find where hydrogen is. Okay, or if you have copper, then just find where copper is. Then for the IP students, you need to take note, you need to consider whether is it acidic, what kind of medium you have. And then from there, you choose respectively, whether is it H+ or is it water. Then for the anode side, same thing, Cl minus versus OH minus. So you send all your N ions there. And then what happens is for O-level students, choose OH minus. For IP students, you have to remember the series and where water is. And then if OH is lower, choose OH. If water is lower, choose water. Okay, so you choose the substance that is lowest in the respective series. Everyone clear? Okay, anyone have any questions? Anyone who is lost? Okay, if you're lost, please do sound off in the chat itself. I can repeat again. Okay, I guess all is good. Now, we are going to look at concentrated electrolyte. So I deliberately put the concentrated electrolyte beside the dilute so that you can see the difference. So if you go back to question 3 and then you look at the aqueous electrolyte, and then what you see is a concentrated electrolyte, then what you need to do is same thing. So here, the example I've given is a concentrated NaCl. So same thing, what you need to do is dissect out the salt, Na plus, Cl minus. For water, for O-level students, water, H plus, OH minus. Then for IP students, just need to take note, you cannot split it up. So you have to consider water on both sides of the cathode and the anode. So same thing, you send all your cation ions to the cathode. So here, for the cathode side, I have Na plus, H plus, or water for the IP students. Then basically, take note, cathode don't change. Still based on reactivity series. So you choose the one that is lowest in the position. So the lower the ion is, the more likely the ion will get discharged. So in this case here, out of these three, H plus is the lowest, so H plus will go out. Okay, so that's for the O-level student. For the IP student, what happened is same issue. You have to consider whether is it acidic, neutral, or basic. So if it's acidic, H plus is lower. If it's neutral or basic, water is lower. So you have to discharge out H plus for acidic electrolyte and water for neutral and basic electrolyte. Okay. Next, at the anode side is where things change. So take note, when you change an electrolyte from a dilute electrolyte to a concentrated electrolyte, the reaction that changes or the electrode that is affected is actually your anode. So your anode is the one that is being affected. Your cathode remains the same as before. It's only the anode that changes. So what happened at the anode? So if you see, at the anode side, I will have Cl minus, OH minus, as well as water for the IP students. Now, this is where you will have to base it on something called the concentration effect. So what is the concentration effect? So number one, concentration effect only affects two types of ions. the Cl, Br, and I minus ions versus the OH minus ions. Okay, so in those scenario, what happened is for O-level students, what happened is if it's dilute, usually we choose OH. But if it's concentrated, we don't choose OH, we choose Cl, Br, and I. So this one will win. Okay, so take note. So Cl, Br, and I are preferentially discharged over OH minus. So in this case here, this is the equation you're going to get. Okay, next, for my IP students, no, for Ryan, take note, sodium don't get discharged. So this is based on what we see in A levels. So in A levels, when we want to choose, we will look at something called the E naught value. Sodium by right is not supposed to get discharged. But obviously, I think some teachers, sometimes they like to play with you lah. So normally what happens is the question always take precedence. So if the question by right, if the question tell you is sodium get discharged, then you just go with the flow. If not, then you should just use based on the reactivity series. Understand? So basically, it's always use reactivity series unless the question says otherwise. But usually the chances are quite low. So if the question is otherwise, maybe your teacher's knowledge is not that great lah. Okay, just saying. Because sodium by right is not supposed to get discharged. If you logic sense wise, maybe I try to convince you all this. Based on what you learn in reactivity series, sodium is a very reactive metal. Am I correct? So what happened is, it's a very reactive metal. The compounds it forms is very stable. So Na plus is very, very stable. So there's no reason for Na plus to want to get discharged and become the less stable sodium metal. So number one, sodium by right not supposed to get discharged. What if it's something like zinc? So take note lah, it's always going to be H plus unless it's copper. You just use the reactivity series to help you. Because whatever that's above hydrogen is more stable than H plus. So it will not get discharged. Ryan, okay now? Yeah. So think that the reactivity series also reflects the stability of the ion. So the lower the ion is, the more stable the less stable it is. So the more likely it will get discharged. So between Zn2 plus and H plus is less stable, H plus should go up. Okay. Now back to this. So back to the concentrated electrolyte. For my IP students, take note, your way of thinking is also a little bit different. So in the dilute electrolyte, like what I say, you have to remember this series and you will choose the one that is lower in position. So what happens is when it comes to concentrated effect, what you are looking at is Cl minus versus OH minus, or Cl minus versus water. So in this case here, same thing, your Cl minus will be preferentially discharged over OH minus and water. The reason is because I think some of you have heard of this thing called the Le Chatelier's principle. Okay. So based on this concept called the Le Chatelier's principle, what happens is when the concentration is high, by Le Chatelier's principle, the Cl minus concentration will cause this reaction to go up. So let me write. So I think this is in response to those who are coming from Nanyang. So Nanyang girls, I think you all learn about the E naught value. So when you learn about the E naught value, you will be looking at this reaction here. Okay. So let me just pull out what I have. Give me a minute. Wait. So the O-level students just chillax a little bit. This doesn't really concern you. Okay, so plus 1.36. And then the one involving water. Sorry, so in A levels, we technically don't need to memorize all the half equations, okay? So it's all given to us, which is why I need some help to remember. One with water should be this one, plus 1.23. Okay, so basically for those of you who are from Nanyang Girls, as well as from Hwa Chong lah, okay, those IP students. So basically what happened is you learn about this thing called the E naught value. The idea here is this, so when your Cl minus is, when you have a concentrated electrolyte, your Cl minus concentration is super high. So by Le Chatelier's principle, the position of equilibrium shifts left and the backward reaction is favored. So what this would cause is the E naught value to start to decrease. So the E naught value will be lower than plus 1.36. So it will start to fall. And then what happened is it will fall not just below 1.36, but it will decrease below plus 1.23. So as a result, that's why you choose Cl minus over water. Okay, so this is for the IP students discussion. But if you're not from IP, if you're taking O levels, then you don't need to learn all this. What you need to remember is just choose Cl, Br, and I over OH. Okay, so if you're from O levels, just need to remember this. Choose Cl, Br, and I over OH. But if you're from IP, you may need to know why you choose Cl over water. So this is for the IP students. Okay, that's all I have for this. So this covers the three scenarios involving inert electrodes. Can I just ask, anyone have any questions here? Okay, so think of that. For concentrated electrolyte, your cat ions by right not supposed to be affected. But if the question says that the cat ion is affected, then just go with the flow. Okay, but by right not supposed to. Everyone okay not? If not okay, can always raise up your question. I can immediately answer you because then it will also benefit the rest. For hydroxide ion, okay. 4 OH minus 4 molecules of it due to balancing. Yes, you need to balance. So that's why you put 4 here. So this one just memorize. Okay, so if it's molten electrolyte, is it possible for the electrode to be reactive? It is possible, but then it doesn't fall under here. Okay. Now, when do you use selectively discharge and when do you use preferentially discharge? Selectively discharge and preferentially discharge are both acceptable O-level terms. But when do you use selective and preferential is when you need to choose. So for example, when you need to choose, then obviously one will be selected or preferred over the other. So that is when you use those words. Molten, because you don't have to choose, you don't have to use the word selective or preferential. So you just say it discharge. So that is answering Shivani's question. Then Claire's question, is it possible for the electrode to be reactive? It is possible, but then it's a whole different ball game, and that's what I'm going to go through next. And then I hope, Ryan, I answer your question. It's due to the balancing, but like what I say, for this equation, just hard memorize rather than to try and derive it out on your own. You don't have the time to do so. So the anode reaction, usually I would advise students to just memorize. Whereas the other reactions is quite easy, so you don't really have to memorize. Only the OH minus one, you should memorize it. Everyone good? Okay, so in response to Claire's question, if the electrolyte is molten, is it possible for the electrode to be reactive? Yes. But when you're dealing with reactive electrodes, technically the electrolyte is not very important. So this is where we come back to question number 1. If your electrodes are reactive, then basically what you need to do is you need to think of this whole idea here. What do I mean by this whole idea here? So basically what you need to do is you need to focus on the electrodes. What will happen to the anode? So when you have reactive electrodes, your anode will do oxidation and your anode will dissolve. So the metal anode will oxidize and then it will form the metal ion, which will then enter the electrolyte. Next, how about the cathode? Now, the thing with cathodes is this, I would say that if you know in the world of acting, right, cathode is like a calefare. It's like, you know, in a TV scene, he stands at the back, but he doesn't do anything. So same thing, your cathode, even though it's reactive, it does not participate in the reaction. Then some of you will be thinking, oh, then what happens? But if you look at what your teacher has taught you, usually what happens is at the cathode, the actual cathode don't participate in the reaction, but the cation ion in the electrolyte will be preferentially discharged. And how do you choose? Based on reactivity series. So take note. So basically what happened is we will look at the metal cations inside the electrolyte, and we must also remember to include the cation from the anode. So between all the cations inside the electrolyte, you just see which one will get preferentially discharged at the and this is based on the reactivity series. Okay, so what happened is reactive electrodes is where things starts to become very fun because there is a lot of applications when it comes to reactive electrodes. So what you can do is you can do an electrolysis using reactive electrodes. You can do electroplating and you can do electrolytic purification. Now, unfortunately, I could not include all of this inside the notes. So what I would want you to do is to kind of take photos or take screenshots of what I'm going to present to you next. So let's start off with A, electrolysis using reactive electrodes. And I'll teach you how I use this idea of thinking. Okay? Okay, so if you all take a look, so I'm going to do electrolysis of aqueous NaCl or molten aqueous NaCl, okay, with copper electrodes. So my copper electrodes are reactive electrodes. So what happened is, let me just put back my electrodes. So remember what I taught you. First thing is look at the battery. The long side is positive, the short side is negative. The electrode that is attached to the long side will be positively charged, and the electrode that is attached to the short side will be negatively charged. So the positive electrode will attract anions, so we call it the anode. And this anode is your copper anode. Next, this electrode, which is attached to the negative terminal, will attract cations, so it's the cathode. Okay, so first thing is we know that this is the anode and this is the cathode. Next, we think of the framework we use. So the first question we ask ourselves, is the electrodes inert or reactive? Okay, so it's reactive. So in this case here, when it's reactive, what you need to remember is anode will dissolve and then cation in the electrolyte will come out. So we start off with the anode first. So, but before we start off with the anode, what I would perhaps need to do is, let's break up the electrolyte. So the electrolyte that I use is aqueous NaCl. I have Na plus, I have Cl minus, I have H plus, and I have OH minus. For my IT students, you just need to use water in replacement of H plus and OH minus. So this is in my electrolyte. So what I need to do is, I need to send my Cl minus and my OH minus to the anode side. So as you can see, I send them there. But at the same time, I also know that my anode is copper anode. So what happened is, if you recall what I have presented to you, this idea here, anode the metal anode will oxidize and turn into a metal ion. So basically what happened is this Cl minus not important. This OH minus also not important, because what is important is the copper anode. So the copper anode will dissolve to become copper ions. So in a sense, if you think about it, this is an oxidation reaction because it went from 0 to +2. So your copper anode oxidizes to form copper 2 ions. So eventually what will happen is, as your copper starts to become copper ions, copper 2 ions, your anode will slowly start to dissolve and disappear. So it will become smaller and smaller in size. So what happened now is, in your electrolyte, you don't just have Na plus, Cl minus, H plus, and OH minus, but you also have copper 2 plus that comes from the anode. Next, let's see what happens at the cathode. So at the cathode, you have Na plus, H plus, correct? As well as copper 2 plus coming from the anode. So remember what I told you. So if you go back to the framework again, the cathode don't participate in the reaction. The cation ion in the electrolyte is discharged based on reactivity series. So what happened is, the copper cathode, not important. What is important is the cation ion inside the electrolyte. Who will get discharged? Based on reactivity series, copper 2 plus is the lowest in the reactivity series, so copper 2 plus will come out. So what you will see is a red, brown, pink solid that is deposited on the cathode. So the cathode will start to become fatter and fatter. So that is how you apply the rules of reactive electrodes. Actually, if you think about it, with reactive electrodes, the whole idea is anode dissolves, move over to cathode, and go up the cathode. Correct? So basically, that's the whole idea there. Okay, now with that, if you want, you can take photo. This will supplement you for your electrolysis using reactive electrodes. So this is the discussion that you should do for your exam. Okay, now we have two more applications we want to go through. So what happened is, the second application, if you see, B, electroplating. So let's talk about electroplating. Now, if you recall when you did metals, am I correct? When you did metals, you remember there's this protection method called galvanization. So basically, galvanization is whereby you put a layer of zinc on your iron object. So that's what we're going to do today. We're going to do galvanization, but galvanization, basically the whole process to do galvanization is electroplating. So what we're going to do is we're going to plate a layer of zinc onto an iron object. Okay? Now, what happened is, you remember what I was telling you just now, it's always anode dissolve, move over to cathode, go up the cathode. So what happened is this, your electrodes, what you need to do is, you put the plating metal, which is the zinc metal, at the anode side. Then you put the object that you want to plate, the iron object, on the cathode side. So what will happen is, the zinc will dissolve, go over to the cathode, and go up and plate onto the iron object. Correct? So basically, that's the whole idea. Now, the important thing I feel is the electrolyte. So in the electrolyte, what we can do is, we can have molten electrolyte and aqueous electrolyte. And we need to think of the salt that we will use. So obviously, not to mess up the reaction, we will choose a solution whereby it contains ions of the plating metal. So you want to plate zinc onto iron, you should use zinc 2 plus so that the zinc 2 plus can go up the iron more successfully. So that is one. Now, next thing is, this is where I would need to do a little bit of a decision point. So before I actually go through this electrolyte again, maybe what I'll do is, let me just go through this example, okay? So I have a zinc metal, okay? And then I have my Oscar statue. Okay, wait, let me choose Oscar statue. Okay. So cannot win a real life Oscar, so I will electroplate an Oscar. Okay, so what happened is, like what I was telling you, the plating metal, you put it at the anode. So where is the anode? The anode is your positive electrode. So remember, the battery got a long side and a short side. So the long side is your positive terminal. So the electrode attached to it is positively charged. It will attract N ions. So that's why we call it the anode. At the same time, the short side is negatively charged. The object or the electrode that is attached to the negative terminal is negatively charged. So that is your cathode because it attracts cations. So technically what you should do is you should put your plating metal, that means your zinc metal, at the anode so that it can dissolve later. And then what happens is the ion object should be at the cathode side. Now, so technically what we understand is with reactive electrodes, the anode will always dissolve. So the anode, which is zinc, will dissolve to give you zinc 2 plus. So that is where you see the zinc 2 plus dissolving and the electrode becoming smaller and smaller. Now, I think a lot of people here will have a little bit problem with the electrolyte. So I'm going to present to you a different electrolyte, okay? So let's say today I use aqueous zinc sulfate. So if I use aqueous zinc sulfate, then what happens is the ions that I'm going to have is, can I answer your question in a minute? So the aqueous zinc sulfate, I will have zinc 2 plus, SO4 2 minus, H plus, OH minus. Correct? So this is inside my electrolyte. Next thing is, based on what we have just discussed, the zinc anode will dissolve. So there's also zinc 2 plus coming from the anode. So number one, we settle the anode first. So the anode, based on what we know, is that the electrode, the ions, the SO4 2 minus and the OH minus that goes towards the anode is not important. What is more important is the zinc anode itself, the metal anode itself, because the metal anode will undergo oxidation and it will form zinc 2 plus ions. Okay? Now, what we want to be more concerned with is the cathode side. Okay, so this is the official answer, but let me just teach you the thinking first. Okay, so now what happened is, at the cathode, I have my ion object. And then at the same time, if I look at my electrolyte, I have zinc 2 plus and H plus that is coming from the electrolyte, as well as I have zinc 2 plus coming from the anode. So out of these three, how would I choose? I would choose the one that is lowest in the series, correct? Because remember what I say, for your cathode, what you need to do is to choose the cation in the electrolyte that will get discharged or that will get preferentially discharged. So what happened is, out of these three ions, the one that is likely to get discharged is H plus. So the H plus get discharged, it forms H2 gas. But that's not what we want. We want a zinc to come out to go onto the ion object, not H plus. So which is why, if you think about it, can you use an aqueous electrolyte here? The answer is no. You should be using molten electrolyte. A molten electrolyte is more suitable. Why? Because with a molten electrolyte, what you are not going to have is the H plus and the OH minus. So if you think about it, your cathode is the ion object, but that is not important. In the electrolyte itself, because it's molten electrolyte, you get zinc 2 plus from the electrolyte. you get zinc 2 plus from the anode. So the zinc 2 plus will safely be discharged and be plated onto the iron object. So I hope through this discussion, you understand what I'm trying to tell you. What I'm trying to tell you here is this. If you look at whether you should choose a molten or aqueous electrolyte, hydrogen should be your cutoff. So what happened is, if hydrogen was present, hydrogen will get discharged. So if you choose any metal above hydrogen and is in aqueous form, that means you will have all this metal with hydrogen. Then hydrogen will get discharged. But that's not what you want. So what you want is, for any metals above hydrogen, use molten. Why use molten is because if you use molten, you don't have H plus. So H plus cannot get discharged, only the metals above it. However, if you have metals that you are trying to plate below hydrogen, then what you can do is you can either use aqueous or molten, because then copper 2 plus will get preferentially discharged over H plus. So I hope you understand the rationale here is that if you are dealing with a metal that is above hydrogen, you should use molten so that you don't have H plus mixed into it that will get discharged. But if you have any metals that is below hydrogen, then you can actually use the aqueous state or the aqueous solution, because in that situation, your metal will get preferentially discharged over H plus. So that is what I'm trying to tell you here. I hope you all understand. Anyone don't understand what I was trying to say? Do y'all get it? Okay, I can give me a minute. But you can't really plate an object with hydrogen atoms though, won't you just get? Yeah, so that's why you cannot use the aqueous state. Because if you use the aqueous state, the H plus come out, you cannot plate the object. So if you think about it, if you have magnesium ions, aqueous magnesium sulfate, you will have magnesium ions and H plus ions. The H plus ions will get discharged, then you will not be able to plate it, correct? I'll repeat again, don't worry. Then next thing is, maybe I just want to answer someone's question. So someone's asking, does the object need to be a metal? Meaning this object that you're trying to plate. The answer is no. So what happens is that the object that you're trying to plate can be made of graphite or can be made of wood. So it can be made of a non-conductor of electricity. Basically, what you need to do is, if you have a non-conductor of electricity, you just need to spray something called a conductive spray so that it can conduct electricity inside the electrolyte. So think that if your object does not conduct electricity, then basically what you need is a conductive spray. So you spray a layer of conductive ions and then they will help you to conduct electricity already. Then it will work. Haiva, I answer your question, right? Yes. Okay, can. Now, I will repeat again. Maybe I'm not very clear. So this time round, this is what I'm going to do, okay? Okay, so I'm going to draw up the setup. So what happened is, what we're going to do is, okay, maybe I just draw a weird statue lah, huh? Like that. Okay. Yes, it's due to no electricity, because if you learn from physics, wood cannot conduct electricity, so it's like a open circuit. So there's a break in the circuit. Yeah. Okay, so take note, I'm just gonna, so this is my object, this is my iron object, this is my zinc metal. Okay. If the anode is not graphite and platinum, then the cathode will be plated with a layer. No, Because platinum is inert, so what we are talking about right now is reactive electrodes. Platinum is an inert electrode, there will be no electroplating. So it will all be whatever we have discussed at the bottom here. Remember, inert electrodes are platinum and graphite, these two. So what you are proposing is not a difference. Reactive electrodes, usually they are made of metals other than platinum. So that is what we are discussing right now. Okay, so you must remember, only with reactive electrodes you can do electroplating and electrolytic purification. Okay, so let me just explain what I was trying to tell you guys, which is how do we actually choose our electrolyte? Okay, so it's not always we should choose a aqueous electrolyte. That is what I was trying to tell you. Okay, so what happened is, if you think about it, so this is my setup. Okay, now I will differentiate the two setup by choosing two different electrolytes. Give me a minute. Every time this thing happens. So what I have here is, I have almost the same thing, but it's just that the difference is I'm choosing a molten zinc sulfate and an aqueous zinc sulfate. Okay, so remember what I told you. First thing is we dissect the diagram. So this is the long side, this is the short side. So the electrode that is attached to the long side, which is the positive side, is our anode. And the electrode that is attached to the short side, or the object that's attached to the short side, is the cathode. Now, basically in reactive electrode, what you want to do is, you want the anode to dissolve, you want it to go over to the cathode and go up the cathode. Am I correct? So basically, that is what you want to try to do. So that's why you put your zinc at the anode, your iron object at the cathode. So the object that you want to plate it, you put it at the cathode. The layer of metal that you want to plate, you put it at the anode. Okay, so first thing is, so once we dissect the diagram, then what we do is we look at the electrolyte, we split it up. So if you look at the electrolyte here, molten electrolyte, I have zinc 2 plus, I have SO4 2 minus. Now for the aqueous electrolyte, I have zinc 2 plus, I have SO4 2 minus, I have H plus, and I have OH minus. So this is what you will see inside the electrolyte. Okay, so now let's talk about what happens with the anode first. So based on what we have discussed here, anode will always oxidize or will always dissolve to form metal ions. So basically, on both sides, your zinc, so you have zinc anode, you have SO4 2 minus. Here you have zinc anode, you have SO4 2 minus and OH minus. But for a reactive electrode, the anion is not important. What is more important is the zinc anode itself. So what will happen to the zinc anode? The zinc anode will oxidize to form zinc 2 plus. Don't need the stay symbol. Okay, so as you can see, on both sides, the zinc 2 plus will go into the solution. And then your electrode will start to become smaller and smaller. Yeah, I'm trying to explain. Just give me a minute. I'm trying to pause here. Wait. Okay, I'll explain to you. Number one, because with a reactive electrode, the anions is just not important. So basically what happens is when you have reactive electrodes, the anions are not important. The anions, nothing will happen to them. So they will just stay inside the solution. So we don't really need to care about them because they are not going to be preferentially discharged. When you have reactive electrodes, the anode will dissolve. So it's the electrode that will participate in the reaction and the anode will dissolve. Priscilla, is that okay? Okay. I saw one question. Dilute aqueous, will it bear the same result? Yes, it will. Okay, so coming back to this, now what happened is, what I was trying to explain to you guys was what is going to happen at the cathode. So please pay attention. So at the cathode side, so what happened now is, on both setup, there is zinc 2 plus coming from the anode. Okay, so now let's take a look at what happens at the cathode. So at the cathode is my ion object. I will have zinc 2 plus. At this side here, on the right-hand side, my cathode is also the ion object. I will have zinc 2 plus and H plus. Okay? Now, what happened is, if you recall what I told you, with reactive electrodes, metal cation is like a calorifer. It will not involve in the reaction. What involved in the reaction is the cation in the electrolyte. They will be discharged based on the reactivity series. So what happened is, if you think about it, for the molten electrolyte here, so molten electrolyte here, what will happen is the zinc 2 plus will get discharged to form zinc metal. So basically what happened is, in your ion object, there will be a layer of zinc metal. Which is what you are trying to do because you are trying to electroplate the zinc onto the ion object. However, if you have an aqueous electrolyte, be it whether dilute or concentrated, what will happen is the H plus will come out because H plus is lower in the reactivity series. So 2H plus will give you H2 gas. So what you will end up having is not a layer of metal, but you will have H2 gas surrounding the object. Is that what you want? That's not what you want, right? So that is what we are trying to see. Based on this, you can come up with the conclusion that if the metal is above hydrogen, it should exist in molten state, not aqueous state. Because if it is in aqueous state, there will be H plus ion, and the H plus ion will come out to form H2 gas, and you cannot do your electroplating. Understand? So basically, that's what I'm trying to present to you on how you should choose your electrolyte. Is it molten or is it aqueous? The answer is it should be molten because if it's molten, then you don't have the H plus coming up. Then you don't have the issue of not achieving your electroplating. Like what I think someone was saying, like what Ryan was saying just now. Okay, I hope everyone can understand. Anyone still cannot catch the ball? Okay, if you cannot catch the ball, please do sound off. Then probably what I'll do is I'll just explain to you after 6. All good, Okay, I got 2 more things I need to discuss. So let's do this quickly. The last application I need you to learn is electrolytic purification. So in electrolytic purification, basically what happened is, it's almost the same idea. Basically what happened is, you put your impure metal with the impurities at the anode, you put your pure copper at the cathode. So basically the whole idea is, inside the pure, okay, so if you think about it, basically what happened is, this is my impure copper. So my impure copper has the yellow color region, which is the copper metal itself. And then I have all these impurities, which is represented by all these like black dots. So basically remember, anode, the copper, the metal will dissolve. So the pure copper will actually dissolve. Okay, so the pure copper will actually dissolve to form copper ions. So basically what happened is, as the yellow region starts to dissolve, you will end up having something like this. So your impurity will start to fall to the bottom of the anode. Then your pure copper will dissolve. Then the pure copper, which is present in the electrolyte, will then get discharged out. Okay. Now take note, in this scenario here, the electrolyte will remain as blue always, because as the copper leaves the solution to go up the cathode, there is copper ions coming from the anode side. So, which is why the electrolyte will not decolorize. Okay, anyone have any problems here? Hey, if you have problems, please do raise up so that I can tackle your problems. Okay, everyone good? Okay, with that, that is the end of, okay, does the copper, yes, it has to be pure. Because if it's not pure, then technically your pure copper from the impure sample go up. If it's not pure, you're still going to contaminate it. Am I correct? So basically what happened is you are sending the pure copper from the impure sample up to the pure sample to make the pure sample bigger in size. So it has to be pure. Okay, the anode sludge thing is basically, when the impurities, right, inside the impure sample start to fall to the bottom and then it forms like a small hill. So we call that the anode sludge. It's basically like your rubbish, your impurities lah. So the anode sludge is where all the impurities are. Okay? Won't the impurities also react at the cathode? No. So we assume that the impurities is not supposed to be reactive. So that is what? Okay, I know some of you, but this is more of an A-level thing. So even the IT students also should not be tackling this. There is some impurities that may dissolve inside the solution, but it will not go up the cathode. Okay? If you want to know more about that, that is more in A-levels. Can the electrolyte be another cation salt? Technically, try not to, because like what I say, if you sure. Okay. Try not to use a different salt, because then you kind of will mess up the whole reaction. So usually what happens is same thing. When you want to look at your electrolyte, choose a ion that involves the purifying metal, which is in this case here copper. Okay. Wait. Suddenly got a few questions. Okay. Yeah. Okay, can the electrode be of other metals? Yes. So if you are doing electrolytic purification of zinc, then it will be impure zinc at the anode, pure zinc at the cathode. Then your electrolyte should involve something related to zinc. What if there are other impurities like zinc inside the impure copper? At O levels at IP, we treat it as it will all fall into the anode sludge. Okay, but in A levels, it's a different thing. Can an impure anode electroplate an object? Gwen, two different things lah, huh? Okay, here is trying to purify an impure thing. So technically, we try not to use an impure metal to go and electroplate something lah, okay? Because like what I said, things will get messy. So even your exam questions will not go into that extent. In a sense, they are very clear cut, meaning that they will not mix this part with this part. Understand? So what you should assume is that this part here, when you are doing electroplating, the plating metal should be a pure metal. Okay, it should not be an impure metal. And then here, this part, what happened is definitely strictly just pure and impure. So don't try to combine too many things together. Okay? Gwen, okay now. Okay, so both the metal impurities, yes, John, you are kind of correct. But technically, like what I say, A levels, O levels and IP will not go into that extent. Okay, so they will not tell you the different types of impurity. You just need to know impurities in general will just not go up the cathode. It will just dissolve at the anode or fall to the bottom as anode sludge. So the impurities will just fall to the bottom as anode sludge. Then your pure metal will just dissolve and then go up the cathode. I know. I think some of you, if you read textbooks, they might tell you different situations. What certain metals will dissolve, certain metals will fall to the anode sludge. But that is strictly too complicated. Even my A-level students cannot handle that, as I'm teaching them now. So O levels, strictly, they will not talk about it. So don't stress yourself on it. Okay. Everyone can understand this, huh? I hope you all can understand. So basically what happened is, just remember, impure anode, the copper at the impure, in the impure anode, the copper at the impure anode will dissolve to form copper ions. Then the impurities will fall to the bottom. So your copper will be inside the solution. Then it will get discharged out at the cathode to form pure copper. Okay? Okay, now, final thing. So basically, this is what you need to know about your electrolytic cell. With that, then we move on to the easier one, which is electric cell. Now, electric cell is quite simple. Basically, is you just need to ask yourself, is it just copper or are there any other metals? Technically, purification, okay, O level, A level, they like to use copper as an example, but can other metals come out? Definitely. Okay. Okay, next, electric cells. So basically, what is the difference between an electric cell and an electrolytic cell? Electrolytic cell is you use electricity to generate chemical reaction or to, spark off a chemical reaction. In electric cell, basically what you're trying to do is you use chemical reactions. Okay, you use chemical reactions to generate electricity. So it's like the reverse. So basically what happened is electric cells are basically your batteries. Simple cell is a battery, fuel cell is also a battery. It is there to provide you with electricity. Okay, so if you are dealing with a simple cell, take note, number one, the two electrodes cannot be inert. So the two electrodes must be reactive. If you have an inert electrode, then the battery cannot work anymore. So what happened is, basically, you start off with the framework, you ask yourself, between the two metals, which metal is more reactive? Now, based on what we know about reactivity series, the more reactive metal tends to undergo oxidation. So oxidation means that it will form the anode. So if you see, between zinc and copper, zinc is more reactive. So zinc will form the anode and it will undergo oxidation. So when you look at this oxidation reaction, it produces electrons because oxidation lose electron. So the electron are produced out. So what I need to do then is to send my electron over to the other side. How do I send my electron to the other side? I put a negative charge here to repel it over to the other side. So that's why if you can see, anode in an electric cell is negatively charged, but anode in an electrolytic cell is positively charged. So here, this is positive, but here, the anode is negative. Okay? Next. So your electron, you send over to the other side. And then what happens is the cathode is there to accept the electron. So you want to attract the electron, it must be positively charged. Once again, this is the difference. Electric cell, cathode positive, but in electrolytic cell, cathode negative. So I hope you can see this difference. So as a result, why you need the electron? Because reduction reaction will allow you to gain electron. But is it the cathode gain electron? No. So take note, the less reactive metal will form the cathode, but the cathode always don't participate in the reaction. So the electron will be at the cathode side waiting for the cation to accept it. So your second question is, you look at in your electrolyte, what will get discharged? So which metal ion? And take note, because the anode has already dissolved and it forms the zinc 2 plus. So you must also take into account the zinc 2 plus coming from the anode side. So which metal cation will get discharged? So once again, it's based on reactivity series, lower the better. So always choose the one that is lowest to get discharged. So if you can see, the zinc 2 plus, the zinc metal dissolve to form zinc 2 plus. In your electrolyte, there is copper 2 plus, there is H plus, and there is zinc 2 plus. So copper 2 plus, H plus, zinc 2 plus. So the copper 2 plus and the H plus comes from the electrolyte, and the zinc 2 plus come from the anode. So based on these three, you just choose the one that is lowest. What is the point of electric cell? Produce electricity. So very simple, just need to remember, electrolytic cell use electricity. Electric cell produce electricity. Okay, Ryan? Okay, lastly, fuel cell. Take note, for fuel cell, what you need to remember is the case study that they want you to remember is H2 and O2 fuel cell. So basically, H2 is your fuel. And for those of you who are doing organic chem, you know that a fuel will need to undergo oxidation. So you should place it at the anode. Your O2, yes, it can. So technically, it can merge as a question. That's possible. Your O2 is you just give me a minute. I'll just go through one a setup like this lah. Okay. So what happens is your O2 is your oxidizing agent. It will be placed at the cathode because an oxidizing agent always undergo reduction. Now what happens is there is two possible electrolyte that could come out. My advice to my student is always memorize. Okay, so just memorize the fuel cell reaction. There's no hard way, there's no easy way to go about it. So just memorize. Then last but not least, if you need the difference and similarities, these are the difference and similarities. Okay. I just want to talk about the last difference. So just need to remember for the last difference, anode, because attract anions, which has negatively charged, so anode is positive. Cathode, which attract cations, will be negatively charged. So this is how you remember. For electrolytic cell, you use the battery. For electric cell, basically what happens is anode will need to repel the electron. So electron negatively charged, your anode need to be negatively charged. Cathode attract electrons. So electrons is negatively charged, you want to attract it, it must be positively charged. So basically that's the difference. Okay, now I think someone was asking, can a simple cell and an electrolytic cell merge together? Yes, it can. So basically what happens is the setup in which they will draw will look something like this. Okay, so you have copper metal, zinc metal. So take note, this is your electric cell. Then it will attach okay but on the bright side okay, don't cry, okay? On the bright side is usually if they merge it with an electrolytic cell, they will not give you reactive electrodes So they will give you inert electrodes like platinum. So it will look something like this. Okay, how do I dissect the diagram? Let me teach you. So what happened is, if you think about it, this is the electric cell, right? You look at the two metals. Which one is more reactive? Zinc. So more reactive metal will form the anode. Less reactive metal will form the cathode. Okay, so let's take, for example, this one is maybe, let's say it is copper 2 sulfate. Okay, so what happens is at your anode side here, the zinc will dissolve to give you zinc 2 plus. So the electrons will be produced out, electron come out. Negative terminal. So which means that on your electrolytic cell, this is the negative terminal. This is negatively charged. So which means that this is your cathode. Because negative terminal attract cations. So it's the cathode. Now, what will happen is the zinc will go into the solution. So inside this electric cell, the electrolyte will have Cu2 plus, SO4 2 minus, H plus, OH minus. At the same time, also got zinc 2 plus. Out of all this, the one that is lowest in the reactivity series is copper 2 plus. So the copper 2 plus will become copper metal, okay, plus 2 electron. So as a result, take note, this will be, you will start to see copper metal forming. Now remember, the electron must come back to here. So this one must be positively charged, which means that this is your positive terminal. This is the anode. Then what is going to happen here? You just think about it depending on what electrolyte you get. Okay? Okay, now there's a few things I need to settle first. Number one is I set the worksheet, but I didn't really have time to go through. I think some of you might still have some questions. So what I'm going to do is this. I'm going to give you the answer to the worksheet itself. You go back and try it out and work it out yourself, okay? What I'm going to do is I am going to give everyone my okay, I'll give everyone my Telegram handle. If you have any questions you want to ask with regards to electrolysis, you can always just Telegram me. Okay, give me a minute. I'll give you the link to the answer. Now, what I want you all to take note of is, can you all take note of this question in the TYS, okay? So in the question in the TYS, which is the 2025 TYS question, okay, so take note, this is the 2025 TYS question. Yeah, I'll send the worksheet. Give me a minute. I'll do everything at one shot. I just want to talk about this question first because I think this question can really test you on your understanding of electrochemistry. So if you look at the 2015 TYS question number 5, go back and try this question out. It can really test you on your understanding of electrochemistry. So basically what happened here is that if you can see how I dissect the diagram. So this is my long side, this is my short side. The long side will be positively charged, it attracts anions, so this is your anode. The short side, negatively charged, it attracts your ions, so this is the cathode. Then if you look at the electrolyte, so we think of the question, number 1, are the electrodes inert or reactive? Inert, because they never say it's reactive, so you can assume it's inert. Number 2, is the electrolyte molten or aqueous? Aqueous. Number 3, is the aqueous electrolyte dilute or concentrated? Dilute. So from there, what happens is you split up the salt, Na plus, Cl minus. You split up the water, H plus, OH minus. Na plus and H plus send it to the cathode. But what happens is H plus is lower in the series, so H plus become H2. So that's why you collect H2 gas. Next, Cl minus, OH minus is sent to the anode. OH minus is lower in the series, so OH minus get discharged from O2 gas. So that is where you have the equation here. And then what happens is when you combine these two equations, this is the overall equation you can get. Now, this question, part A, not difficult. What is difficult is part B. And I will actually urge all of you to actually kind of take a photo of this. Okay? Now, number 1, the first question that they asked the student was, why was the ratio of the volume ratio 2:1? So you need to link back to what you learned in mole concept, which is mole ratio equals to volume ratio. Now, if you look at the equation itself, the mole ratio is 2:1. So the volume ratio will also be 2:1. Okay? So what you need to explain or what you need to include in your answer is how you link up the two questions together. So this part, for every 4 moles of electron transferred, is very important. So you tell me, because to link these two equations together, the number of electrons must be the same. So because of these 4 electrons, you get 2 moles of gas, H2 gas, and 1 mole of O2 gas. So the mole ratio 2:1, so the volume ratio is 2:1. What is interesting is they tell you that oxygen is actually very soluble in water. So when oxygen is soluble in water, that means it can dissolve in water, it cannot be collected as a gas. So which means that theoretically, I would expect to collect 1 unit of O2 gas. But what happened is the actual volume that I collected is actually lesser than 1 unit. So let's just assume that 0.2 dissolve in water, which means that 0.8 will be collected. So what happened is if you recalibrate this ratio, you realize that in comparison to 2:1, the ratio becomes 2.5:1. Now, why is this important is because the question asks you, explain how the ratio is affected. You cannot say that the ratio changed. You need to tell me, is it higher or is it lower? So this maths part will show you that it's higher. So the ratio becomes higher, okay? But what happens is, as time progresses, your water can only hold so much of oxygen gas, correct? So once it is at its maximum capacity, then the oxygen gas cannot dissolve any further. It will start to be collected. So in the beginning of the experiment, you will see the ratio is 2.5:1. But in the long run, the ratio will become 2:1. Okay? Now, finally, in part C, is also a typical electrolysis question. They will say what happened to the electrolyte as your electrolysis process goes on. Basically, what you need to tell me is what ions are discharged, what ions are left behind, and what is the consequence of it. So for example, H plus and OH minus are discharged. What you are left with is Na plus and Cl minus. So the volume of water decreases, the concentration will increase. So take note, B and C is very typical electrolysis question. You will definitely see some sort of something in this type of question coming up for your WA2. Okay, with that in mind, okay, I am going to flash this out in about 3 more seconds. Please take a screenshot. Okay, then I'm going to give you the answer key, but let me upload the answer key onto the drive first. Yeah, I'm going to stay back after this to answer any of your questions. So if you still have any questions, you can always stay back and ask me. I know it's dinner time, but I'll try to keep it as short as possible. Okay, so okay, this is going to disappear in 3, 2, 1. Okay, can. Okay, so now let me just give everyone the answers. So the answers to the worksheet that is found inside the notes, it's here. Give me a minute. Okay. Now, just let me allow me 2 seconds to just do some advertisement. So if you are interested to join the tuition, these are the list of pure chem lessons there is. You can just scan this QR code for the various timings and how to sign up. Okay, so I'll just leave this here for like maybe 5 seconds. Okay, alternatively, you can just go to the OVERMUGGED website. Okay, 5, 4, 3, 2, 1. Okay, finally, I think all of you are just looking for this. So scan this QR code for the worksheet. Yeah, for the answers. Can you also show the notes for each page? What is the notes for each page? My own notes. I uploaded it. I uploaded it to this drive. So actually, technically, if you scan this QR code, you will get the worksheet, you will get the summary notes, as well as you'll get the answers. Yeah. I just never put the answer at the start is because if not, then everyone will just, take the answers and leave. So yeah, I have just uploaded the answers. So inside it's the same Google Drive link lah. So you should be able to find all 3 items that you need. The summary notes itself, what's the thing called? The summary notes, the actual notes plus the worksheet itself and the answers to the worksheet. Okay. But more importantly, I think go and look at the 2015 answer. So I hope all of you got screenshot that answer. That page just now that I showed you. The final page before I move on to here. Okay, so I will stay back. If you have any questions, please do type in the group chat if you need. And then if not, then all the best to your WA. I hope you manage to understand something. Okay, Ken. Oh, how electricity is produced? That one is physics already, so you don't have to stress. You just need to know that the reactions will produce electricity. But I'll explain again lah. But technically, take note, you don't have to know how electricity is produced. Okay, can let me just explain. Thanks, Gabriel. John, you wait for me. Okay, okay, I will explain what is hydrogen fuel cell. So if you're interested to learn about hydrogen fuel cell, yeah, I will explain it now. Basically, hydrogen fuel cell is like a type of electric cell. Wait, So basically what happened is that you will have this setup. As you can see, this is the setup you will get. Give me a minute. So this is the setup you will get. Basically in a hydrogen, in a fuel cell itself, there are 2 things that you will need: the fuel and the oxidizing agent. Now, obviously in the syllabus itself, they ask you to focus on hydrogen as the fuel, but potentially other fuels come out. Yes, like you learn about organic chemistry, methanol can be a fuel as well. So all of that can be, it can be used. So what you need to do is you need to remember in organic chemistry, you learn that a fuel will undergo oxidation. So when it undergoes oxidation, you should put it at the anode. Okay, so at the anode side is where you feed in the fuel. Then at the cathode side, because it undergoes reduction, you put in your oxidizing agent, which is technically most of the time oxygen gas. So oxygen gas put at the cathode, the reduction, where reduction happens. The fuel, put it at the anode where oxidation happens. Then basically what happens is the H2 will undergo oxidation to form H plus if you have an acidic electrolyte, and the O2 will undergo reduction to form water if you have an acidic electrolyte. At the same time, the electrolyte may become an alkaline electrolyte. So if it's an alkaline electrolyte, then basically it's H2 become water, O2 reduced to form OH minus. So my advice to you is really hard memorize this. Okay. Now, as a benefit for those who stayed behind, just let me explain something. So fuel cell, basically, where are they used? They are used in rocket ships to produce energy. So what happens is this, you have a fuel cell, correct? So what happens is you feed in the H2 and the O2 inside to the fuel cell produce out energy. Correct? Now, if you look at the product is usually either water, in both sides will have water. So which means that water will be produced. Now, what happens is, if you think about it, in a rocket ship, you cannot hold so much H2 and O2 gas, correct? The rocket ship don't have so much space to hold the H2 and O2 gas and then hold all the satellite and all the equipment. So basically what happens is you just need to use a tank of H2 and a tank of O2, put it in the fuel cell, let it produce energy. As it produces out water, you put it through an electrolysis experiment or an electrolytic setup, and then it will give you back the H2 and O2. So it will just keep recycling in this way. So then you get endless supply of energy. Basically, the idea of a fuel cell is endless supply of energy. So the difference between a simple cell and a fuel cell is fuel cell, the energy will be continuous as long as you got reagent feeding into the cell. Simple cell is once the electrode is gone, then this simple cell is dead. So no more energy. That's the difference between the two. John, are you okay? Yeah, so just need to hard memorize the equation. Okay, technically, in this topic, there's only 4 equations to memorize, because if you see this cathode reaction, right, it's the reverse of what I asked you to memorize earlier. Remember this? So this one, you reverse it, this reaction, you reverse it is your cathode reaction for an alkaline electrolyte. Okay. Okay, anyone else got any question? Yeah, just go ahead, shoot your questions if you have any. Oh, can I explain simple cell again? Can. Okay, so basically in a simple cell, what happens is you will need 2 metals. Okay, so you put 2 metals, you connect them with a wire, they will actually start to produce energy for you. So basically what happens is when you have 2 different metals of different reactivity, what you need to think of is one of the metal which is more reactive will be your anode. So the one that's more reactive will be the anode. It will undergo oxidation. It will dissolve to form ions, and then at the same time, electrons will come out. So as you can see here, zinc, zinc is more reactive, so it forms the anode. It undergoes oxidation. It loses electrons, and electrons will leave the anode to go over to the cathode. Then the cathode is where reduction happens, but the cathode does not participate in the reaction. So what participates in the reaction is the electrolyte. So a certain cation in the electrolyte will pick up that electron and get preferentially discharged. So you just need to see which cation will get discharged. The idea is based on reactivity series. The lower, the better. Then as this reaction happens, then you will get electricity. Is there a pH change? That one really will see what kind of electrolyte you use. So that one, I cannot say for certain. It's really a case-by-case basis. How does zinc get oxidized here? Because zinc is more reactive, right? So if you recall on the idea of reactivity series measures the ability of a metal to undergo oxidation. Since zinc is more reactive, it tends to want to undergo oxidation more. So that's why zinc will do oxidation, because it's more reactive. Then copper, less reactive, will just have to take precedence. Oh, but what is the force driving? This one, A level. You just need to know that it will spontaneously do it. It's not really, even in A level, they also doesn't really talk about what is the force driving the oxidation. It's just that I guess the force that drives the oxidation will be its reactivity law, because it's more reactive compared to copper. So it has a higher tendency of want to undergo oxidation. Yeah, but there are other factors, but it's not very important. Okay, all the best, John. If you ever is interested, I teach at Coven on Sunday 10 to 12. If you're ever interested in coming for tuition. Okay, anyone else? Brian, are you okay? If you're asking me what is the force, that one you have to maybe ask the physics people. Because in chemistry, technically the reaction is what we like to call as spontaneous. So the force that drives it is, I would assume, is number one is reactivity, or in A levels wise, we will look at something called E0 values and delta G values. But O levels, you don't really need to understand what is the force that pushes it. I hope I answer your question. Oh, cause like for oxidation is current that flow through the single cell that makes it oxidize. I feel like got nothing. In a sense, not really though. It is the one that is producing the current. It's not the current causes it to oxidize. So maybe you just think of it more like the metal is reactive. So the metal will react to give you the current. Because ultimately, that's what a electric cell is to generate electricity. Right? But what is that driving force to cause it to do oxidation? You can think of it as the nature of the metal itself. So the nature of the metal is that it's a reactive metal, so it will tend to undergo oxidation to produce out the electrons so that the current can move. Does that answer you? Yeah. But you are thinking a little bit too in depth lah. Usually, if you are dealing, are you from O levels or IB? Oh, even IB, they also not that deep lah. Technically, even A levels are not that deep. So in A levels, we just know that the driving force is basically this thing called the E0 value. So the E0 value, if you look at it, you can actually calculate the delta G value, and the delta G value can actually show you that it's spontaneous. So the reaction will just naturally happen. Another way you can think about it is this, maybe some of you do not know, chemical reactions in general, why chemical reactions happen is that it's trying to achieve greater stability. So if you think about it, zinc metals doesn't have an octet structure. But if it loses the 2 electron, it will have an octet structure. So maybe that is also why it wants to do oxidation more, correct? because it wants to lose that 2 electron to form a full valence shell. So that is perhaps the driving force behind why it undergoes oxidation. Do you think that is a better answer for you? Or better reasoning for you? There's a lot of reasoning. So basically, I think in IPS, I would use the idea of achieving a full shell. So that drives it to undergo oxidation. Okay. Anyone else? I left 4 people, is it? Priscilla, are you okay now? Just now I think you asked some question. Hopefully I got the answer your question. Okay. Oh, yeah. So take note, Priscilla. So in the case that if it's reactive electrodes is the one that take precedence. So the anions inside a reactive anode is not very reactive. Okay lah, but to be honest with you, if you are from IP years, technically, eventually you will learn, or if you are going to JC or you are looking to take A levels, eventually what happens is when you're looking at all these ions, they all have a certain E naught value. So in A levels, basically we just choose the E naught value. Okay, example it gave, what is the, okay, wait, let me take a look. Which example are you talking about? On page what? Oh, 155. Okay. 155 not in this chapter, right? Oh, 139. Okay. Okay, 139. Because the negative electrode is the anode. So remember what I say, negative electrode is the anode. H2 is your fuel. So fuel will tend to undergo oxidation. And we all know N-ox rate cat, so that is where it happens at the anode. So your H2 will undergo oxidation. Because technically the fuel here is a sodium hydroxide, so it's a alkaline electrolyte. So for alkaline electrolyte, the H2 will actually produce water. But if it's an acidic electrolyte, then the H2 will produce H+. So different electrolytes, different products. Then on the other side, positive electrode means cathode. So O2, which is the oxidizing agent, undergo reduction at the cathode. So your O2 will undergo reduction to form hydroxide ion. But take note, all of this is inside a alkaline electrolyte. In an acidic electrolyte, your O2 will form water. So acidic electrolyte, different scenario. So you just need to remember what the H2 and O2 becomes in an alkaline and an acidic electrolyte. Does that answer your question, or are you still lost? You're still lost. Okay, can. Okay, if you have any more questions, you can always telegram me at this handle. I think this is my handle. Let me just double confirm. If not, then I need to end this session because I have a class at 7 at Bishan. Wait, let me see. Is this my handle? Yeah, it is. So if you want, you can just telegram me at this handle lah. Okay. Yeah, then I will answer any of your questions.